Good morning, dear 10th class students. Now we already discussed in our earlier classes that reflection of light and how the images can be formed by the spherical mirrors. Okay, the different type of spherical mirrors like the concave mirrors and convex mirrors and uses of that. Now today we are starting the refraction, which is one more phenomena is regarding about the light. Okay, so this is the refractions. May you are just hearing this word not before of that. Okay, and reflection you already hear in 8th class. Okay, so what are the main difference between the reflection and refraction is that reflection is just reflect the light from the one part. It means the from when they are the incident to the one surfaces, and then they are just reflect and bending in just reflecting to the other side. But what will be the new cases and new images will be formed due to the reflection is that a bending of light. Okay, a bending of light when a ray of light when enters from one medium to the another medium. Okay, so first of all you have to write the definition of refraction of light. Okay. You also have to note down. Okay, this is the obliquely. So what is the definition of reflection of light? Then a ray of light when propagate means they are just going from one place to another and bending on entry one medium to the other medium obliquely. Okay, obliquely means to making an angle. So when one light is going from one medium to another medium, maybe the medium is air. Okay, the glass and maybe the water, so they are the medium through which a light can be propagated. So when they are just entering from one medium to another due to different optical densities, they are making obliquely. It means to making an angle, they are just change their path, actual path. Okay, and make a new path. So that's why this is known as the refraction of light. Okay, and how this is refraction is happen, so you can see through this diagram. This is air, this is glass. Okay, okay, so look at this. When one ray of light which is entering from one medium, maybe the one medium is here, it is air, then this other medium is glass, and then again when this light is going from glass to air, then we can represent air is a one rarer medium, okay, and glass is a denser than air. Okay, I am telling denser than air, it means it is not too much dense, but when we are making a comparison with the air, then glass is a more dense in comparison with the air. So this is the rarer medium and this is the denser medium. So what are the postulates we have to identify with this phenomena, that this is the incident ray, okay, when they are just entering into the more dense another media, okay, then it is just bends towards the normal. It is just bends towards the normal. So we have to write that when a light rare to denser move, then bending towards normal. Bending towards normal. And when light denser to rarer, it means entering, then bending away from normal. Okay, so you have to see here, this is the normal. Okay, you have to see this is the diagram to represent how the light is just enter from rare to denser. Okay, so this is the incident ray, this is the refracted ray, okay, and this is the emergent ray. Okay, that's why this E is known as angle of emergence, and this is lateral displacement. Lateral displacement. Okay. So if I can tell that what is the lateral displacement, then what is this? So it is the only difference, that is the actual path of incident ray to the a new path of refracted ray. Okay, new path of refracted ray. So this is the path of refracted ray. Okay, this is also refraction, because when we are telling this is the incident ray, this is the refracted ray. But if we are telling that this is the incident ray, then in the case of this is the refracted ray. This is the refracted ray. So this is the difference in between the actual path. Okay, so when I will see that incident ray actual path, if I am just removing this glass slab or maybe the rectangular glass slab which are making the refractions here, then this is the actual path of here and this is the refracted path. So the difference of, and both are parallel to each other. Okay, both are parallel to each other. So this is the lateral displacement, is the difference between the actual path of the incident ray to the new path of refracted ray. So E is the angle of emergence, and this is the R, you know about that, angle of refraction. Okay, and I is the angle of incidence. I is the angle of incidence. So you have to draw it. Now one more phenomena we have to understood here. Okay, that is laws of refraction. Laws of refraction. The incident ray, refracted ray, and the normal at a point of incidence. Okay, so only the new things I am showing here. Okay, older ones you already knows about that. Okay, like this is I, small I is the angle of incidence. You knows about that. It is made when the incident ray is just making with the angle of with the normal. Okay, this is the earlier one, and this is the R. And earlier we already discovered that is the reflection, and here it is the refraction, angle of refraction only. So only is the difference here. So now you are more clearly knows about that. What are the main differences between the reflection and refractions? Okay, refraction is just the bending of light with the oblique rays. The bending of light when enters one light into the one media to the another media, that making with the angle, that is the refraction. And reflection is simply a light is just back towards the another direction after striking the plane surfaces, after striking to the plane surfaces. Okay, so at a point of incidence, the incident ray, the refracted ray, and the normal at a point of incidence all lie in the same plane. All lie in the same plane. Next is okay, the ratio of the sine of angle of incidence to the sine of angle of refraction is constant. Is a constant for a given pair of media. Given pair of media. Like that, if light is travel from like that. Okay, so this is the and that is the refractive index and constant also, constant, that is the sin I upon sin R. Okay, so this is the refractive index. It means the n is equal to sin I upon the sin R. Okay, so what are the two laws of these refractions? You have to see the incident ray, the refracted ray. Okay, here you can watch the main differences in between the laws of reflection and laws of refraction. Okay, so refracted ray and the normal at a point of incidence all lie in the same plane. It means in the same plane there are all these three. It means the normal and the refracted ray and incident ray will be held. The ratio of sine of angle of incidence to the sine of angle of refraction is a constant for a given pair of media. It means if we have to write two media, like one is glass and then other one is water, it means maybe the light is going from glass to water or water to glass, air to water, air to glass, anywhere, then there is a difference between the sin I upon the sin R. You know about that sin I is the angle of incidence will be the main in the first pair of first media, and then another one sin R will be the refracted ray, will be the, it means the more dense. It means the first one is rarer, then other one is the denser, then the for the rarer the sin I will be the angle, and for the denser then sin R will be the it means the dense. For the denser this one will be the angle. Okay, so I hope you are understanding here. Okay, so this one things first we have to write down these things. Now we are understanding the two type of refractions. Okay, it is the refractive index. Okay, okay, first one you have to write this thing. So then now students, we have to see the two type of refractive index, that is the relative refractive index and absolute refractive index. Okay, so first one is relative refractive index. Okay. And second is absolute right. Writing should be continued. Okay? Instead of entry of light, refracted. Refracted, more suitable word. Okay, so what are the main difference between the relative refractive index and absolute refractive index? Look at when a ray of light refracted, it means when a ray of light refracted from one medium, okay, refracted one medium to another, but that one medium is not vacuum or air, it means maybe different from the vacuum or air, then maybe from water to glass or glass to water, then is known as the relative refractive index. But absolute refractive index, it means when a ray of light refracted, but at least one medium is should be air or maybe the vacuum, then to another medium is known as absolute refractive index. Then we have to write okay. So this is the example for that. Now we are starting. It is the speed of light. like that. So approximately the speed of light is 3.0 into 10 raised to power 8 meter per second. Okay, like that, speed of light 3 into 10 raised to power 8. Okay, so you have to at least remember that the speed of light in air or vacuum both are approximately same. So 3 into 10 raised to power 8 meter per second. Okay. Next is spherical lenses. Okay. Next is spherical lenses. So a lens is a transparent substance which has capacity to convert or diverse the light. Okay, a lens is a transparent substance which has capacity to convert or divert the light. Okay, now you know about that spherical lenses is two types, convex lens and concave lens. Okay, sometimes we are taking some more type of lenses, but actually they are the combination of in between the two lenses. Okay, maybe the convex or concave. So on the broad spectrum there are only two types, that is first is convex lens and second is concave lens. Okay, both nature are just different from the concave mirror and convex mirror. Okay, so you have to also notify that. Okay, so a convex lens means a lens which can convert the light. A lens which can convert the light. So spherical lenses means lens is a transparent substance which has capacity to convert or divert the light. Those are having the convert or divert the light. Okay, so if there are any chances of numerical problems regarding this refractive index, then the solution is like that. It means there are three things in between that. Then the refractive index of the substance, like maybe the air, glass or water. Then there is a chances of given of three types of numerical things, and in this way we have to given already in the questions two things, and we have to identify one out of that. Okay, so speed of light in air, you know about that. The speed of light in air is the 3 into 10 raised to power 8 meter per second. Okay, so this is the light speed in the air, and other one is may be asked into the question. So one question I already taken for that. So refractive index we have to given for one glass, like that is the 1.50, for air that will be the 1.00 like, okay, and speed of light already given in air, that is the 3 into. So first of all we have to put the values in this formula, that is the nm is equal to c upon v. C is here, it is the speed of light in air, okay, and v which we have to, the speed of light we have to calculate the speed of light in the another medium. So that is 1.50 is equal to 3 into 10 raised to power 8 upon x we have to put, okay, then make the cross multiplication here, x into 1.50 is equal to 3 into 10 raised to power 8, then x is equal to 3 into 10 raised to power 8 upon 1.50, then our answer will become that 2 into 10 raised to power 8 meter per second. So this will be the speed of light in the another medium, okay, that is the other than air, okay, that is the other than air, and that is the, I think, the speed of light in the glass medium, okay. So this is the one more questions, okay, numericals may chances to come in your board exams regarding the refractive index, okay. So now we are understanding, okay, and this is the NCERT questions also. So now we are talking about the shape of the convex lens and concave lens, okay. So this is the convex lens and this is the convex lens and concave lens, okay. So now some terms regarding these lenses we are studying here, okay. Okay, first is convex lens, we already know about that. A lens which can convert the light, it means having the convergence ability, okay. So look at here. So you already seen this type of lenses in the magnifying glass. Our palmetry is generally using this type of lenses to see some things broader, okay. So first is, this is the C point, between point. So first is optical center, you have to write them, optical center. So what is the difference here? This the midpoint of reflecting surfaces, okay, in the mirror, that is known as the pole, okay. But here it is the midpoint of this transparent substances is known as optical center, okay. So now the principal axis. Four pins. So look, you have to see this. So you have to see the terms, okay, in the concave and convex lenses, that is optical center, okay. So you already know about that. What is convex lens and concave lens? Convex lens have a converge the light. It means having the convergence ability, and the concave lens have the diverge the light. It means having the divergence ability. So first of all, few terms are just related to these lenses we have to study here. That is the first is optical center. The midpoint of transparent lens is known as optical center. The midpoint of this transparent lens. So both are both nature is like a transparent lens is known as a optical center. That is the capital C. We have to denote it with the capital C. Now the principal axis, a ray of light which is passing through the optical center. So this is the a ray which is passing through the optical center, and one more we have to add if here, that we have to tell that a ray of light which passing through the optical center, and on this line the principal focus will be the form. On this line the principal focus will be the form. Now the principal focus, a ray of light after converging in convex lens intersect or meeting at a point. So after converging this lens meeting at a one point, this is known as principal focus in the convex lens, and a ray of light after diverging in concave lens appears to be a coming light, a bright spot. Okay, so when you will watch here, if it's in the front of that, then you will see that light is coming from the one bright spot, because the light is just like a, sorry, this diagram is all right. You have to make once again. So why I am writing here a bright spot? Okay, look this, because a bright spot is known as, when you will see from here, then the incident light which is parallel on their to the principal axis, after coming, it will, after divergence, it can be look like a bright spot in it is behind this surfaces of the lenses. Okay. So the light will be the divergence, it is having the diverge, okay, after it is passing through this lens, and light will be the converse at a one point after passing through the convex lens, okay, after passing through the convex lens. So you have to write here, and next thing is, this is the principal axis, this is the C, optical center, okay, and this is the distance from C to F. It means optical center to principal focus is known as focal length. Is known as, you have to understand first here, after that you have to write. Okay. So this is the distance from optical center to principal focus is known as focal length. And here it is like, this is the C and this is the focal length. Okay. Because here it is the F. Okay. So first you have to write these things.